as we promised at the beginning, our big aim for today is predicting the Ericsson share price. So let's see the code. So firstly, we have we imported the library pandas, NumPy, and the scikit-learn. Scikit-learn is one of the most kind of important machine learning libraries. And the Keras is also very important. It's on top of TensorFlow. Probably like people would know more of TensorFlow rather than Keras. So yeah, the TensorFlow is created by Google people. So the Keras and TensorFlow, they are really very good and very reliable. So in the machine learning, roughly we have three main steps. So let's say the first step would be the data pre-processing. We covered earlier, and once our data is ready to go, then what we do is build a model with the training data sets. In these machine learning libraries, they normally use the term fit when we describe the building a model. So we use a fit function here. And once our model is ready, then what we can do is predict a model. Predict an unknown data sets. In our case, it's going to be our test data set. Okay, so what machine learning algorithm I will use here? I will use 4 machine learning algorithms for today. So one is the SVM, support vector machine, artificial neural net, AINN, and convolutional neural net, CNN, and long short-term memory, LSTM. So what we want is compare the performance of those 4 models for our data sets. So let's have a look what I've done. Yeah, so as we just mentioned, the first step is data pre-processing. So for that, I read this CSV file. Yeah, and here it's very kind of simple project, so we didn't need a database. I just read the data from CSV file directly. And oh, I think we mentioned this as well. So for the time series data, we cannot use the, well, yeah, we don't use the cross validation, because the we understand the beauty of cross validation, which we can reuse the data sets again and again and again when we train the model. But unfortunately, if we divide the sequence and combine them together, then we will lose some of most important information, the sequential information. So I'm not gonna use the cross validation here, but I'll just use the first 8% of data sample for the training, and the next 10% for the validation, and the rest, which is 10% for the test sample. That's how I will tackle these issues. All right, and so what we want to predict is stock price, and especially what I want to predict is close stock value every day. So in here, close value would be, okay, the 0 indexed zeros, and the first, second, third, fourth. So I want 4th index to predict the close value. So in here, read the data, column start from 4th indexed and stop before 5th. So which basically means I already use the 4th column. That's it. Okay, and yeah, there's some pre-processing, especially what I was doing is just reformatting or reshaping our data sets to fit to our models. So each model kind of expects a different shape of the input data sets. So I just made a, each data set for the kind of each model, if that kind of makes sense. Okay, so at that stage, I say the pre-processing is done and we are ready to go. So next step is building a model. For the support vector machine, I'll just use the library, the class from the scikit-learn directly. Okay. And for the support vector machine, we know we don't need, we don't need validation data sets because, as Yash pointed, this support vector machine calculates the best hyperplane there, and then it always gives you the same result. So yeah, we only need a training data set. So you probably, I kind of skipped through it. Because we didn't need validation data sets, I just combined them together, the training data set and validation data set. So only this model, it has 90% of data sets to train model. Anyways, yeah, that's just editor information. Well, our sorry. Yeah, just for the SVM model, we gave the training data set and validation data set together. But for the rest of the neural nets, I gave training data sets and validation data sets separately because they have to compare the performance every training steps. All right. Yeah. So we have an artificial neural net model here, and we are training the model with our training data set, and there's optional arguments you can give them is the validation data. In here, we will give the validation data sets. So each training day can calculate the performance or the error rate. And then callback. I didn't mention it earlier, but let's go back. What's this callback says?
Any chance did you use like batches when you're training it?
Yeah.
Okay. What's your batch size?
I guess that's just the total data as data set size.
Yeah, it's you say like training sample number, validation sample number.
Mm.
No, so I'm talking about batches. So like, you know, like we do, let's say 5 or 6 epochs or 10 epochs you're doing it. In each epoch is like nothing but you take that data set and train it and then, you know, do it same again. But you can't fed like the entire data all together. So you take it in batches, you know, so I would take like a batch of 100, you know, 100, and if you go 1,000 entries, so it'd be 10 batches. So it trains in a batch, each batch at a time. So I think the fit method that you have there, I think it does take a parameter called batch size.
Batch size, yeah. Yeah. And here we omit it. It's
anyway,
just
go ahead.
Fit, or the data set. Yeah, that's really good point, Josh. Yeah. Should have made more complicated architecture here. So actually, I forgot to mention for this guy. In here, I use this normalization from scikit-learn library. So we got this class, we instantiated the class, and what this color does is, firstly, we calculate the mean and standard deviation value from our training data sets to rescale all of our data sets. So we got the numbers, we got the mean and standard deviation from a training data set. Then we are going to apply the same rescale value to our validation data set and the test data set. So it's really kind of fair to rescale in the same scale level. And also I didn't mention in here, so after we predict the test data set, we have to bring it back to the normal scale because that test data set is rescaled by the Z normalization standard scaler. So yeah, that's kind of important.
What's that normalization, right? What's that normalization?
Sorry, yeah, we covered last time, so maybe go back to sorry for that.
What other videos now?
Yeah.
Sorry, go ahead.
Yeah, because we don't have much time left. Right. Okay, so that's the scalar here. So it's like a normalization rescaler data set. And yes, sorry for this again. Yeah, so callback function, I used early stopping, as we mentioned not long ago. As this early stopping is, okay, we will stop once the validation, the performance on the validation data set goes bad. So what we will monitor is the val loss, validation loss, and then I actually give the optional flag here, the patients to 10. Actually, it's kind of interesting concept. So what it is we can of course stop whenever the performance goes like maybe a little worse than before. We can of course stop right ahead, but then I don't want that. I just thought maybe this training was a little bit not really set correctly. So it was just like a one time and the error performance goes like a little bit fluctuated. So in that case, I just want to watch 10 more times and see if the performance goes better. So it was kind of one-time event that the error rate goes up. So yeah, that's the argument here. So I'll watch 10 times more and see if it was an accident. That's it. And yeah, so sorry, excuse me. So we train the model with the training data set, validation data set, and I set the maximum epoch number to 1000 and the callback to early stopping. So yeah, the most important part is done, training is done. So then we want to predict the unknown data set. In our case, it's test data set. So we have the outputs. Then of course we have to bring it back to the normal scale. So that's all done. And as we mentioned, I want to measure the performance of the model. So root mean square error here, just to compare the performance of the machine learning model. So for example, what we will get is, it's just an example. Like what we will get is, okay, we have let's just say the error rate, that there are error rate of like 25% from SVM and 1.5% from AINN, 2.2% from CNN, kind of stuff. Then we know which one looks better. For me, AINN looks the best here. So then I will just pick this machine learning model at the end. That's the kind of reason I calculated this, the RMSE and the mean, sorry, give me a sec. Yeah, the mean absolute percentage error. So these are two the performance metrics. Okay, yeah, the same thing goes to the CNN, Convolutional Neural Net, and then we train for the long short-term model, which is recurrent neural net as well. So at the end, I'll just plot it, and so we can see what was the output. So here we go, and it didn't take too long actually. While we were talking, it just finished the training and prediction as well. So maybe like a few minutes. All right, this is from SVM. The red one is the real data, and the blue one is predicted one. So SVM looks fine. Looks fine to me. Okay. So what's the next? So the next one was artificial neural net, and it actually looks better for me. Like it kind of fits pretty well. So I kind of prefer AINN here. Okay. And what's this? It's convolutional neural net. Actually, yeah, it looks pretty precise, pretty accurate. It's like nearly 100% accuracy, I think. So this is good as well. Then the LSTM, the long short-term memory. You see, it actually performs worse than the CNN or AINN. I will probably touch this on why we got this. Okay, so the total looks like this, just all together. So I probably you cannot see that, but the black one is the real value and the rest are the predicted value. And for me, the blue one looks, or the blue or the yellow one looks the best. We will see which one was the best. So interestingly, LSTM didn't give me the best one. Right, so yeah, looks like it's LSTM got me like a 4% error rate, and the CNN was 1.8%. It's like 1.9%. So yeah, CNN is the best among them for today. And yeah, the SVM to perfection machine is 25%. This is an interesting result, but I'm kind of thinking why we got this result, because I kind of expected the LSTM would give me the best result. Okay, and so I was thinking why we got this result, why deep learning didn't get me the best one. Well, the CNN did, but so what I'm thinking is maybe the architecture I used for the deep learning wasn't good enough. I probably should have done more experiment and find the best architecture, like a number of layers or like a number of cell neurons and stuff. So yeah, maybe I need more experiments. The second one is, I think, yeah, I'm kind of suspect of this. Maybe the data wasn't enough. So for example, the data what we used here was, although it was like a 10 years, whatever, historical data, but still it was like 10,000 sample. I don't know if it's enough, because normally for the time series data, probably you would expect maybe like a couple of hundreds, thousands maximum, minimum, I think. I don't know.
I trained mine with like 60,000. I had 60,000 individual gyras. So and each title had like probably on average 10 birds. So So yeah, data could be like, I mean, I wish I had more knowledge on it. I gotta learn more about it. What's the correlation, like size of the data on the recurrent neural networks or LSTM? At the moment, I just don't know. Like, but it does have an impact.
Yeah, absolutely. It does have an impact, and there's nothing I can do because I cannot create like, well, I can use maybe more granular data sets, like maybe hourly data or like
Or you pay
minutes.
like, you know, pay some money and like use those professional services that can provide you like 100 years of like data, but you got to pay a lot of money.
Absolutely, you're right. Yeah. And another thing I kind of suspect is, yeah, maybe the data was too simple, like you know, like unstructured data and versus structured data. Well, time series is good for actually, sorry, it's the other way around. The deep learning is actually good for time series data set, but maybe mine was maybe little too simple, maybe. And so in that kind of case, maybe I needed more attributes, maybe like what's the economy index like, or what's the like unemployment index like, and so on. So I can suspect that, and probably I can train again. But yeah,